try. I do not know whether more I'll be successful or not. Please let me try. This is looks like a scientific calculator. Can you see this, More? Hello.
Yes, sir.
So
Yes.
44.8 to the power. So to the power minus 0.8 equals to something. No, it is not working. So how do you do that? 40 C 44.8 to the power should come here. To the power minus 0.8 is equal to this into 210 plus 15. More, can you see it is 25.027?
Yes, sir.
Okay, so you must be making a small
Actually, sir,
mistake
I was
somewhere.
taking 45 instead of
No, no, no,
44.8.
no, 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 don't do that. Don't do that. Till first decimal place, second decimal place, you have to take. So this is done, and I would suggest a modification. Actually, no, no modification. Let it be 20. Yeah, okay, no, let us do a small modification. Okay, so this is 25.03. Now you are going to calculate FT. For calculation of FT, FT would be calculated as FT would be calculated as UG into MRR divided by VS. And please recall MRR is VW into W into A 2 comma 1. Okay, because you are calculating it for F 2 comma 1. So how much is it? Anyone? You have
Uh,
to be more faster.
200, 224.26.
Let me write down whatever you are saying. 224.26.
26.
I think there is a mistake by one decimal place. It is 22.42. So can you recheck your calculation?
Yes, sir. Yes.
Okay. So this is 22.42. So this number will come out to be 22.42. If this is 22.42, this is 2.5 times that. And as previously done calculation, it is 56.04. 56.04. So delta would be Fn 2 comma 1 divided by Kn. So Kn was taken as 10. So it can be taken as simply 5.6 micron. So this one would become 40 plus 4.8 minus 5.6. So how much it would be? Let me see. It would become 39. It would become 39.2. At this stage, it is very important how we have arrived at this number. This is very, very important. So this is 40 because this is set. This is coming from pass number 1. This was unmachined. This was not machined earlier. This was not ground properly. So this was remaining. And this is the deflection in the first iteration of the second pass. So in the second iteration, this is the value. Now you can calculate UG2, this FN 2.2, FT 2.2, FN 2.2, delta 2.2, and arrive at this. So any one of you or all of you can start giving me numbers. I'll check with my previously done calculations and I'll confirm it. Please go ahead. So how much is UG 2,2?
26.15.
26.16. Acha, can any one of you tell me why it is more than this? This was 25. Now it is becoming 26. What could be the reason? You are using a equation, that is a different thing. But what could be the inner reason? Variation of UG with A is like this. Earlier my A was 44, so it was somewhere here. Now it is 39, so it is somewhere over here. So definitely as downfeed decreases, as downfeed decreases, UG increases. This we have learned in the last class. Okay, now how much would be FT 2.2? 2,2? How much would that be? All of you, you need to participate. I cannot only depend on one or two of you. Please participate in the class.
20.5.
20.5. Who is it?
Ritesh.
Ritesh. So are you the 20.5? Okay. Now there is one more interesting thing. How come my UG increased but force is decreasing? This is 20.5 and earlier my force was 22.5, 22.4. So force is decreasing. Who can explain this? Anyone, please give a wrong answer. Please try to participate in the class. Ashok More, would you like to say why the force is decreasing? Specific grinding energy was increasing, but despite that, force is decreasing. What could be the reason? Ashok More, are you still there?
Sir, because A is decreasing.
A is decreasing. So it is law of nature. Simple questions. If you participate, A is decreasing, law of nature, you are removing less material. So if you are removing less material, possibly you have to give less effort. As simple as that. If someone would like to give a complicated answer, UG is decreasing, increasing, but MRR is decreasing because A has gone down. This increase is not being compensated by MRR, it is overcompensated, so FT is decreasing. But much more scientific answer is, which is not dependent on any mathematics, is that your effort is decreasing because you are removing less material. So Fn would be 2.5 times of that, which would be, should I hazard a guess?
51.2.
How much?
51.26.
51.2. So 51.2 Newton. So this is 5.1 micron. This was 5.6 micron. Now this has become 5.1 micron. So this would become 40 plus 4.8 minus 5.1. So this would be how much? 39.7. Am I correct? Hello. At least is this arithmetic correct or not? Is 39.7 okay? Okay, you people would not respond, so I have to go back to my Excel sheet. 39.7 is okay. Now I have taken a significant amount of time, so let me go back to this Excel sheet and explain it directly to you. So this is my Excel sheet. What I have done in that Excel sheet, let me see. Okay, can you see it now?
Yes, sir.
Okay.
Yes, sir.
Fine. Now just wait a bit. Okay. This was our hopefully fast pass, and finally we came to a number deflection which was 4.8 and total removal of 35.2. So in our Excel sheet we are going to check that first. So what is it? So here I would not be able to annotate possibly. Or let me see, review, start inking. No, it is possible. It is possible. Okay. So this is my pass number. So all these are for same pass, pass one, pass one, pass one. This is iteration within pass. This is 0th iteration. So in the first pass, set value is 0. Deflection from the previous pass is 0. There was no previous pass, no history. Effective downfeed is 0. Actual material removal is 0. No deflection because nothing been done. Everything is, this is UG, this is FT, this is FN. These are set parameters. This is U0, this is X, this is VS and all that. So these are everywhere it is there because I am not very good at Excel programming. So I cannot use constant. I have filled it in. You people might be knowing how to use constant and laughing at me, but I can't help. At least I have tried. Okay. So in the first pass, you give 20 micron, 40 micron. In the previous iteration, there was nothing. So 40 plus 10. In the previous one, there was nothing. So this becomes 40. So actual material removal, we do not know. This also becomes 40. So I calculate UG. I calculate FT. I calculate FN. And from this, I calculate delta. So from this FN, this delta is calculated. How it is calculated? It is 51.96 divided by 10, which is, good God, this is 5.196. So that was taken as 5.2. So that 5.2 comes in. Next pass, AS remains 40. There was nothing from the previous pass. So this becomes, total becomes 40. 40 minus this 5.2 becomes 34.8. If you go back to your calculation, you will also get to see. And after 3 iteration, once again, we are reaching 4.8. As because this is Excel, I do not have to press any button. I continue till the 10th iteration. And from 3rd iteration onwards, everything is same. So at the end of iteration, first pass, what is the total deflection? 4.8. It comes over here. Now, then what becomes 80 in the second pass, first iteration? 40 plus 4.8, 44.78. There was nothing in the deflection, so it becomes 44.8. I have just done something over here, rounding off. So rounding off I have done, and then this cycle continues. So I have this 25.03. You people have calculated this. This was 22.42. You have calculated. This was also calculated by you, and they are matching. So your calculations are fabulous. And then it becomes 5.6 because it is 56 divided by 10. And then in the next pass, it becomes 39.2. Why does it become 39.2? Because 40 plus 4.8 from previous pass becomes 44.78 minus 5.6. It is the previous iteration. So this is the value of A. This is once again a guess value. And from that guess value, we calculate all of them and we get 5.1. And if we carry on our iterations, we find out after 5.2, that's our final deflection. And if we carry on this particular process, for the 3rd iteration as well, this becomes 3rd pass as well, this becomes 5.2, and you will see that this is gradually approaching 40. For the fourth pass, it is once again 40, and the deflection has saturated to 5.2. Then fifth, as because it has already saturated, I have assumed that till 10th pass, same thing will repeat. You can do it, it will be done. In the 11th pass, this will remain 5.2. So whether it is 5, 4 or 10 doesn't matter. It will be same. So 11th pass, this will become 5.2. This would become 0 because in 11th pass, operator has not given any feedback. So this becomes 0 plus 5.2. This becomes 5.2. There was zero deflection in the previous iteration. So this becomes 5.2. And once again, the cycle continues. And after the 11th pass, you are left with a deflection of 3.6. I have not continued it. You can build such a Excel sheet and the whole calculation till 13th, 14th or 15th pass, still your deflection is only 0.1 micron or so, so that the desired tolerance is achieved. Now let us go to this ones. In the 11th pass, we assumed this to be 8 because I simply assumed to be 8, but actual calculation shows it was only 5.2. Okay, so in this way, using Excel and the numerical approach, one can solve the entire problem. One can solve it. One can solve the grinding simulation. And if one solves the grinding simulation problem, what would happen? He will get this kind of graphs. This is A. Oh God. This is A. This is P. So gradually your actual downfeed would increase. It will remain stable and it will fall. What will happen to UG? Now let us use this and see what will happen to UG. In the first pass, your final UG value was 27. In the second pass, it was 26. In the third pass, it was 25.99. And in the 11th pass, it was 90. So what would happen? Your UG, let us say UG is red. Initially, it would be bit high, then it will stabilize and remain stable. Why would it remain stable? It will remain stable because your actual material removal is remaining stable in the steady state. And then it will shoot up. Why would it shoot up? Because in this segment, A is decreasing gradually. And we know A versus UG variation is like this. So as A decreases in this particular part of the story, UG will shoot up. So all these calculations can be done using this iterative numerical approach, and you can use MATLAB very efficiently. Please talk amongst yourself. If you do not have access to MATLAB, there is a free software which is as good as MATLAB. Using for analytical solution, this can be done once again in MATLAB and in some calculators. It cannot be done in all the calculators. What is the analytical solution? We are trying to find out this quantity. How much is deflection in a pass? As because it is analytical solution, it doesn't require iteration. It is a single step solution for each pass. So this is for pth pass. I need to know Fn by Ft. For our problem, it was 2.5. I need to know UGP. For our problem, UGP was 15 plus 210 to AP to the power minus 0. Come from numerical setting. So this has to be calculated. And this has to be multiplied by MRR into P. That will give you Fn value. There is a mistake in this. If you divide it by Vs, then you will get the Fn value. There is a mistake. What is the mistake? This has to be divided by Kn as well. Stiffness of the spindle. So this has to be divided by Kn. This was missing. So that's done. Now the problem starts. Why the problem starts? This is a number. This is not going to change. What about UG? Let me expand. Is 15. U0, which is 210, minus X minus 0.8. These are known. But this P, there is a AP part. AP part is problematic. This is A. That is whatever you have set in that pass, previous pass, delta P minus 1, this information would be available to you. So this is a numerical value minus deflection in this pass. So this is the deflection that you are trying to calculate, and it is also appearing here. So it is becoming a complex equation. It can be solved in using calculators. Not use us, then it can also be solved using MATLAB kind of thing. So that into MRR. MRR is BW into VW into A. A once again gets basically delta P minus 1 minus delta P. So once again, A becomes part of the deflection process. So here, this is a function of itself, and that has to be divided by Vs, and that has to be divided by Kn. You will get this one. This kind of equations, if you can solve directly in your MATLAB or in your calculate the solution immediately. This is the expression for the fast pass, this one, UG, this is the fast pass, this will become 0. However, this is not 0. This is you are trying to calculate into BW into VW into AS plus this. Acha, this is coming here. So let me. So this is once again 0 because this is the fast pass. This is the fast pass. This is not 0. This is the same thing over here divided by Vs into Kn. Kn I was missing everywhere. So in this way, analytical solution can be done. And if you are doing analytical solution, then iterative solutions need not be done. So I have shown 3 techniques to solve grinding cycle problems. So let me summarize. The first technique is tabular form. In tabular form, there is assumption. What is that assumption? That assumption is not correct. But still we have used just to give you the initial demonstration cycle. Deflection is a fixed percentage of AT. AT is effective downfeed or total downfeed. AT, if you remember, was AS plus delta from the previous pass. This has been used earlier as well. This is our tabular approach. What was the problem with this? Fixed percentage is problem. So after tabular approach, we have gone for numerical. Numerical approach, there is no problem. In numerical approach, deflection is controlled by stiffness. Stiffness is a known quantity. Only thing is numerical approach, to get the final solution, you require iterations. So using a calculator, solving such kind of thing is impossible. So now from your clearing the subject point of view, you can guess numerical problem cannot be set because it will require 1 hour, even if you are using Excel to solve. And whether you are solving by Excel, MATLAB, I don't bother because it is open book. You have the resource, you can solve it. Solving the problem is important. That is up to you. It is to your good faith. I cannot do anything about it. And last one is numerical, where iterations, last one is analytical. Where iterations are not required, directly you get a solution. But in that case, the whatever you are trying to calculate is a function of itself. So solution procedure is bit tricky. You have to use your calculator accordingly, or you have to write a small code in. So if you are writing a small code, someone can say it once again becomes a numerical solution. I do not dispute that, but this is a much more straightforward way to approach it.